Welcome to The Explainer. Today we're diving into quantum physics. And look, this is probably the most successful, most revolutionary, and honestly, the weirdest scientific theory we have ever come up with. It has totally rewritten the rules of our universe.
But hey, before we really get going, maybe a little friendly warning is in order, courtesy of our friends at Nova, because things are about to get strange. We're talking about a world where reality itself just seems to play by a whole different set of rules. You ready? Okay, let's dive in. So you might be thinking, what on earth does the science of the super small have to do with something as gigantic as a black hole? Well, it turns out the answer connects the two extremes of our universe, the tiniest possible scales with the absolute largest. And it all kicks off with a paradox.
Right, so for decades, we all figured black holes were the ultimate dead end. You know, these cosmic monsters that just swallow everything that gets too close. Not even light can escape. But then, back in 1974, Stephen Hawking came along and proposed that these giants actually have a weakness, an Achilles heel. And the reason why? It's all thanks to quantum physics.
Okay, this is where it gets really mind-bending. The idea here is that empty space isn't empty at all. Nope, it's constantly fizzing with these little pairs of virtual particles that just pop into existence and then, poof, vanish again. But if this happens right at the edge of a black hole, one particle can fall in while its partner zips away into space. Now, over an insanely long time, this tiny constant leak of energy means that even a supermassive black hole can literally evaporate. Just gone. So, to really wrap our heads around how that's even possible, we got to understand just how big of a shift quantum mechanics was for our whole view of reality. It was a complete game changer, basically throwing out that old idea of a nice, predictable clockwork universe.
See, in classical physics, Newton's world, the universe was seen as this perfect, predictable machine. If you knew exactly how everything started, you could, in theory, predict the future perfectly. But then quantum physics came along and just blew that up. It revealed that the universe is actually more like a cosmic game of dice. Probability and pure chance aren't just a part of the game, they are baked right into the fabric of reality itself.
And this was such a radical idea, right? I mean, so radical that even Albert Einstein couldn't get on board. He famously pushed back against it, arguing that this randomness was just a sign that we were missing a piece of the puzzle.
So here's the absolute key to all of this. Before we actually look at a quantum particle, it isn't in any one single place. Instead, it exists in this haze of all its possible locations at once. This is called superposition. It's like a wave of pure potential. It's only when we measure it, when we observe it, that this wave collapses and the particle snaps into one definite reality.
Okay, I know this all sounds super abstract, maybe purely theoretical, right? But here's the thing. Understanding and, harnessing these weird quantum rules is exactly how we built the modern world. I'm talking about the technology we use every single day, from the computer in front of you to how we keep track of time itself. Let's take atomic clocks, for example. They basically run our modern world. And they work because of a core quantum rule. An electron can only exist at very specific energy levels, and not in between. To make it jump from one level to a higher one, you have to hit it with a photon, a little packet of light that has the perfect, super specific amount of energy. And that jump, it's perfectly consistent every single time. It gives us a tick with just an unimaginable level of precision.
And just to give you an idea of the insane precision we're talking about, the official definition of 1 second is based on more than 9 billion of these little quantum ticks from a cesium atom. 9 billion. That gives us a universal standard for time, one that's exactly the same for everyone, everywhere.
And that incredible precision? It's not just some lab experiment for scientists. It is the reason the GPS on your phone works. I mean, it's how your phone can take time signals from all those satellites whizzing overhead and figure out exactly where you are, down to just a few feet. That's literally quantum mechanics guiding you to your next coffee shop.
These same quantum principles also gave us the laser. Think about a regular light bulb for a second. That's basically quantum chaos, right? Just a mob of atoms spitting out photons of all different colors in all different directions. But a laser? A laser is pure quantum order. It's a beautiful chain reaction that makes all the atoms spit out identical photons, all perfectly in sync, all marching in the same direction. And that quantum-powered order is so precise that it allowed the LIGO experiment to do something that sounds like science fiction. They measured tiny ripples in the actual fabric of space-time. These were distortions caused by two black holes colliding billions of light years away. I mean, that's a complete revolution in astronomy, and it was all made possible by a tool built on quantum mechanics.
So, if that's what quantum mechanics has already given us, you have to wonder, what's next? Well, the answer involves what might be its strangest and maybe its most powerful feature of all. It's this phenomenon called entanglement. And here's the deal. You can get two particles so deeply linked that they essentially behave as a single object, even if they're on opposite sides of the universe. If you measure one, you instantly know the state of the other one. They have this stubborn, mysterious connection that just exists.
This idea was so bizarre, so completely against all common sense, that Einstein himself famously called it spooky action at a distance. He just couldn't wrap his head around it. He couldn't believe it could possibly be real. And yet, experiment after experiment has proven that it is. But here's the amazing part. Today, that very same spooky action is the key to the next massive technological revolution, quantum computing. And it's all built on a totally new kind of information bit called a qubit. So a classical computer bit is simple, right? It's a switch. It's either a 0 or a 1, on or off. But a qubit, thanks to superposition, a qubit can be a 0, a 1, and everything in between, all at the same time.
So by harnessing both superposition and entanglement, we can build computers that are powerful on a scale that's hard to even comprehend. We're talking about a computer with just a few hundred qubits that could hold more information than there are atoms in the entire visible universe. This is going to let us tackle challenges that are just impossible for us today. Things like designing brand new medicines, creating revolutionary materials atom by atom, or solving incredibly complex climate problems.
When you step back and think about it, the science that seemed impossibly weird, even spooky, 100 years ago, is now the absolute bedrock of our modern world. It's just a powerful reminder that what feels like common sense isn't always the way the universe actually works. And that leaves us with a pretty thrilling question, doesn't it? The quantum mysteries we're just starting to unravel today, what are they going to build for us tomorrow?